Module 14. Coastal Zone and Coastal Processes. 3. Coastal Zone. In this section, we shall get introduced to some terms commonly used while discussing coast. What comes to our mind immediately at the mention of the word coast is the beautiful scene with blue-green water constantly changing its levels and sandy beaches. The level of the sea falls at low tide and rises at high tide. The line of contact between the land and water is called shoreline, that is the actual margin of the land and sea fluctuating. 3. Environmental geology. 4. Environmental geology. From moment to moment with waves and tides. The contact zone between the land and the sea is termed as coast or shore. The terms coast and shore are generally used interchangeably, however, there is a difference between the two. While the term shore or shore zone is used for part of the land-sea interface between the extreme low and extreme high tide levels, the term coast is used to indicate a strip of land of indefinite width that may include the shore and some areas extending seaward and landward of the shore. Shore is further divided into several zones, i.e. offshore, nearshore, foreshore and backshore as shown in Figure 1. Offshore is the zone that extends to the shallow bottom seaward of the breaking waves. Nearshore is the zone between low tide level and breaker zone. Foreshore is the intertidal sloping zones between the low tide level and the limit of high tide level or storm wave effects. The zone landward of the foreshore that is inundated only during large storms and includes beaches, cliffs or dunes is called backshore. There are other terms which have been used in this section, however, we shall get introduced to these terms later in the chapter. Figure 1. Generalized profile of a coast showing different zones. The term coastal zone refers to a broad area that includes the portion of the sea where physical, biological and biogeochemical processes are directly affected by land, and also the portion of the land that influences the sea. Coastal zones are very important because they are highly dynamic in nature due to constant interactions of hydrosphere, lithosphere, atmosphere and also biosphere that continuously shape it. Support important ecosystems such as seagrass, mangroves and coral reef ecosystems that are known for their very high ecological diversity and as a nursery ground for a variety of organisms including fishes. 5. Environmental geology. Contribute substantially to the global economy. Are known as the areas of high population density and growth. Witness intense anthropogenic activities leading to changes in land use, land cover, and receive high influx of land-based pollution and dissolved nutrients. India has a long coastline of approximately 7,500 kilometers including that of its island territories. However, in addition to natural processes, anthropogenic activities like rapid urbanization, tourism development, discharge of waste effluents, municipal sewage, overexploitation of coastal resources are exerting increasing pressure on coastal zones of India, SAC Report, 2012. 4. Processes governing coastal configuration. The term, coastal process, refers to all the activities taking place at the coast. Coastal processes are effective in the narrow vertical zone near sea level and hence are responsible in shaping landforms within the zone limited by extreme tide limits. We shall study about the coastal processes in the next section. Present-day configuration of coasts is a result of the processes that are in action today but also the processes which were active in the past. Coast is shaped by several individual processes such as tidal, wave, subaerial, biological processes, which work simultaneously or in some sequence. Configurations of coasts is not constant, rather it is highly dynamic and is constantly changing according to the nature of the material and the energy changes. According to an estimate of the coastal processes by Inman and Nordstrom, 1971, of the world's coasts about 45% are wave eroded, 36% glaciated, 11.7% wave deposited, and the rest have formed mainly due to river, wind or biological activities. It suggests that wave process is dominant among other processes. Along the Indian coasts too, wave action is important. Let us discuss major processes. 4.1 Waves. The seawater is constantly on motion due to waves, tides and currents. Waves are considered as the major source of energy in majority of the coasts and hence most important agent in shaping up coasts. Waves are undulations of seawater, and have well-defined crests, i.e. highest point of the wave, and troughs, i.e. lowest point of the wave. It is better to define some terms here which will be used in forthcoming paragraphs. Difference between the crest and trough is called wave height and the distance between two crests or troughs is called wavelength. And, the time between two successive wave crests to pass a fixed point is called wave period or wave period of time. 4.1.1 Formation of waves. Waves are produced by the action of wind. Wind disturbs water body as it exerts frictional drags on the surface water particles of more or less flat body of water, Figure 2a. It results in setting up small orbital motions of water particles in. 6. Environmental geology. The water with the largest ones near the surface and decreasing with depth, Figure 2b. Wind pressing on the back of a developing wave makes it steeper and gradually the waves grow bigger. When wind blows strongly for many hours, it increases height of the waves. Size of waves is governed by the following three factors. Wind velocity, duration of the wind, and the fetch, the distance of open water surface over which the wave-generating wind blows. When the wind is strong, wave steepness, the ratio of wave height to wavelength, increases, and when it is not strong, the wave steepness decreases. If the wind is stronger it will blow longer, and when the fetch is greater, the wave will be more powerful, e.g. storm waves. So, length of the fetch is the limiting factor in wave development. A, C, B. Figure 2, A and B show initial stages of formation of waves, and C, wave modification near coast. Waves have circular movement away from coasts that turn to elliptical due to frictional drag when they approach coast. 4.1.2 Wave modification near coast. Waves are generated in open ocean and travel to coast where they break against the land. Wavelength, velocity of the waves and the wave period are the three closely related parameters that modify waves. When waves reach near coast, shallowing of water depth and irregularities of the shoreline result in change in form, dimensions, and mechanics of the waves, figure 2c. The waves slow down but the wave period remains same. Wavelength is shortened but the wave height increases and these result in increase in wave steepness. The wave steepness keeps increasing until it becomes so steep that it breaks. The zone where the waves break is called breaker zone or surf zone. In the breaker zone, the wave force is translated up the beach due to which the water is thrown up the beach, i.e. swash. The water which drains down the beach. 7. Environmental geology. Under the influence of gravity is called backwash, which is either in a sheet flow, undertow, or as a rip current, i.e. a localized concentration of backwash. The initial movement of water in a wave is circular. However, when waves move towards coast, water moves forward on the crest and backward in the trough, changing the circular form to elliptical. Wave steepness is an important factor responsible for making waves either constructive or destructive. When most of the swash soaks into the beach with very little backwash, the waves are called constructive waves or spilling waves, figure 3a. This happens on the gently sloping beaches where waves of long wavelength and low height approach and the ellipse becomes horizontal. When high waves of short wavelength break on steeply sloping beaches, the water plunges forward into the trough, resulting in very powerful backswash that can carry material down the beach. These types of waves are called destructive waves or plunging waves, figure 3b. A, B. Figure 3. Waves gets modified on beaches and changed to a constructive or spilling waves on gently sloping beaches, and to B destructive waves or plunging waves on steeply sloping beaches. There are three types of changes that may occur to wave direction, viz. Wave reflection, wave refraction and wave diffraction. When waves approach a uniformly sloping coast at right angles to the shore, they break simultaneously and all the waves strike the shore in straight parallel lines. When the breaking waves hit a cliff or seawall, water in motion impinges against the structure and the waves are reflected. When waves approach coast, they are also subjected to refraction and or diffraction. Waves refract when waves approach shoreline consisting of headlands and bays, at an angle and each wave impinges on the shallow sea floor before the rest of the wave. This results in slowing down of the section of the wave opposite the headlands, but the section of the wave facing the bay moves shoreward at higher velocity that is still at some distance away from the shore. This relative difference in velocity leads to progressive bending of wave crest parallel to the shoreline. This is known as wave refraction. It causes the wave crest to converge on the headlands and diverge on the bay, figure 4a. This results in high breaking waves and intense erosion at headlands and quieter waves at the bays, thus producing cliffs on the headlands and beaches in bays. When waves approach a barrier obliquely, it results in 8. Environmental geology. Diffraction of waves leading to shadow zone in the lee of the barrier. Waves also diffract when a segment of wave crest passes in river mouth or bay, figure 4b. The currents generated within bays and harbors by diffracted waves erode and transport sediment until the shoreline fits the diffraction pattern. A, B. Figure 4. A relationship between wave refraction and diffraction is observable at the shoreline, and B. Wave diffraction is seen in the form of parallel wave crests in the North Sink Island, A and N, source. 4.2 Tides. Tidal processes are found more dominant on the coasts characterized by estuaries or other embayments. We have studied that shoreline does not remain constant and keeps changing with change in the level of the sea. The rhythmic periodic rise and fall of the sea water is called tide, which is caused by gravitational pull by moon and the sun on ocean. Rise of the sea water is called flood and its fall is called ebb. Effect of the moon is more powerful than that of the sun because moon is comparatively much closer. Tide causes the sea level to move vertically by several meters daily. The gradual rise to the highest level is termed high tide and fall to the lowest level is called low tide. The difference between the level of the low and high tide on a given location is called tidal height or amplitude or range, which may vary from few meters to several meters, e.g. over 15 meters in Bay of Fundy, Canada to less than 2 meters in southwestern coast of India. Variation in tidal height in different locations on the Earth is due to the different forms and depths of the ocean basins and the rotation of the Earth. The difference is more in shallow seas, particularly in narrow channels and straits. Following 4 types of coasts are identified based on the tidal range, i.e. megadidal tidal range greater than 6 meters. Macrodidal tidal range between 4 and 6 meters. Mesodidal tidal range between 2 to 4 meters, and microdidal tidal range less than 2 meters. 9. Environmental geology. Following 3 factors affect tidal movement. Change in the declination of the moon and the sun. Distance from the Earth to the sun and the moon, and position of moon and the sun in relation to each other and to the Earth. Different locations on the Earth's surface are attracted by moon with varying strength because of the changing distance between these locations and the position of the moon. It is also due to eccentricity of the orbit of the moon round the Earth. When the moon is closer to Earth, tides are bigger. When the Earth, moon and the sun are in a straight line, then high tide, spring tide, is produced. When the sun and the moon are at right angles from the Earth, then low tide, neap tide, is produced. Tides are divided into following 2 types according to the period of rise and fall. Diurnal tides occur once a day during the lunar day, e.g. in northern Pacific and Indian Ocean. Semi-diurnal tides recur twice during the lunar day, e.g. in Atlantic Ocean. The coasts with large tidal range such as the Gulf of Kachach and Gulf of Cambay are generally characterized by the presence of extensive mudflats with mangroves and salt marshes. In the coasts with lower tidal range, relatively smaller areas are subjected to daily wave action such as the southwestern coasts of India. Tidal range and topography of the coast determine velocity of tidal currents, which dominate the water movements particularly in bays, estuaries and tidal channels called creeks. This results in tide-dominated landforms. In small tidal inlets, water discharge is determined by the tidal prism, i.e. the volume of water between the high and low tide surfaces, whereas in the large tidal creeks and estuaries, the tide progresses as a wave. In estuaries, flow is of two types. Tidal currents are the most important physical process. Residual currents are chemical or diffusive processes due to the differences in the density of fresh water and salt water. 4.3 Currents. Besides tides and waves, currents are also responsible for coastal modification. Currents are mass movements, vertical or horizontal, of ocean water, both surface and deep, in a continuous flow. Currents are largely generated due to surface winds but can also be created by tides, difference in the density of water, i.e. temperature and salinity gradients, gravity and Earth's rotation. 10. Environmental geology. There may be several kinds of currents. There could be either surface currents, the ones found in the upper 400 meters, or deep water currents found below 400 meters. Surface water currents make up about 10% of the ocean and deep water currents make up about 90% of the ocean. The speed of surface currents is greatest closer to the ocean's surface and decreases at about 100 meters below the surface. While surface currents are generally caused by the wind because of the friction generated by its movement over the water and forcing the water to move in a spiral pattern and thus creating gyres. The gyres move clockwise in the northern hemisphere whereas they move counterclockwise in the southern hemisphere. Gravity also plays a role in the movement of surface currents. In the areas where water meets land, or water is warmer, or where two currents converge, mounds in the water form. Water moves downslope on the mounds under the influence of gravity and thus resulting in creation of currents. The Coriolis force also plays a role in the movement of surface currents and deflects them, further aiding in the creation of their circular pattern. Major current systems typically flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere, in circular patterns that often trace the shorelines. Currents normally move in a specific direction and aid significantly in the circulation of the Earth's moisture, the resultant weather, and water pollution. Ocean currents are the wind-induced major ocean circulations in open ocean. They are major control on the supply of offshore energy influencing wave dimensions, supply of sediments and also biotic factor in coasts. There are many types of currents, however we shall get introduced to the coastal currents. Water flows in a definite direction as a current near coast. Following two broad types of currents are recognized near coasts. A cell circulation system consisting of currents flowing parallel to the coast and rip currents, and longshore currents generated by waves flowing at an angle to the coast. A rip current is a narrow current of water that is generated by movement of water returning back to the sea from beach. It is caused by shape of the shoreline and the current runs perpendicular to beach, figure 5a. Rip currents move along the surface of the water and not underneath the water surface. They are capable of moving coarse sediments from coast. Rip currents may occur in the areas such as gap in a reef or low area on a sandbar where there is strong longshore variability in wave breaking due to presence of jetties, sandbars, crossing wave trains. Generally, rip currents are narrow, however, they may be wider and faster where there are large and powerful breaking waves. Height of shoreward moving waves varies in direction to the shore, causing longshore flow of water from the location of the highest breakers to that of lowest breakers. Further, presence of troughs in the surf zone parallel to the shore. 11. Environmental geology. Facilitates the longshore movement of water and the water reaching the lowest breakers return to sea as strong currents, thus creating the rip currents. The water returned to sea through rip currents is moved back shoreward again, completing the circulation. This circulation of longshore and rip currents is influenced by bottom topography. A, B. Figure 5, A, showing formation of rip currents due to difference in wave setup, and B, longshore currents as a result of waves hitting the coast at low angles, thus drifting the sediments in direction of its movement, i.e. northeast in the image shown here. Source. The speed at which waves approach a coast depends on bathymetry. When a wave approaches a beach, it does not reach the beach perfectly parallel to it. Different segments of the wave reach the beach at different time interval, causing slowing down of the segments. This results in bending of the wave, causing it to conform to the general shape of the coast. Waves coming oblique to the beach also create longshore currents, figure 5b. Incoming waves intercept the retreat of the water that has been carried up the beach by a previous wave. This results in more longitudinal movement of water along the beach between the line of breakers and the shore. It causes the beach material to gradually shift laterally. This type of longitudinal wave may move a considerable amount of sediment parallel to the coast. When the breakers of the incoming oblique waves are of surging type, sediments may be pushed up the beach, and when the waves are of plunging type, sediments may be eroded off the beach and carried away longitudinal to the coast. These longitudinal currents move sediments from headlands or river mouths to downcurrent bays and deposit them there. Currents are also generated due to tides when they ebb or flow. Tidal currents are strong enough to move sediments. In estuaries particularly, the ebb tides are stronger due to reinforced outflow of river water. Tidal currents are considered more effective in shaping up the bathymetry rather than modifying beaches. 12. Environmental geology. 4.4 Other processes. Besides waves, tides and currents, there are several other oceanographic, terrestrial and subaerial processes which are responsible in shaping up the coast, such as ocean currents, wind action, biological processes, fluvial processes, hillslope processes, sea ice, frost action, etc. We shall discuss briefly about these processes here. Wind processes. We have discussed earlier about how wind away from the coast is important for generation of waves. Waves associated with storm also influence coasts. And the locally generated wind waves are also significant. Winds are also generated locally on coasts that may have its effect on the coasts. One example is the sea breeze that blows onshore, landward, in afternoon when land is hotter than the seawater due to differential heating of land and sea. At night, the breeze blows seaward when land is cooler than the seawater. We have read about geological action of wind and know that wind plays a major role in the formation of dunes. It is responsible for development of dunes on coasts by sorting sediments, transporting and depositing them. Fluvial processes. We have read about geological action of rivers and know that river water plays a major role in the formation of several landforms. There are several landforms such as deltas that develop at the mouth of the rivers.